Hello friends, here is the third problem on the topic of friction. Read the problem. The problem states you are shown two blocks. There is a force applied which is parallel to the inclination, this surface, inclined surface. So this A is passed over a pulley and the other end of the rope is connected to B, right? And you want to find the value of P when for the motion to impede. That means it's an impending motion. That means it's going to start moving down. It's about to move down. So at that point, what is the value of P? This is what you are asked. And you know what is impending motion? When the something body is about to move but has not started moving. So at that limiting point, where you can use F is equal to mu r. Only when, in that condition, you can use. And here you can use that relationship. Look here, you are given that the coefficient of static friction at the sliding surfaces is 0.25. You are given the mass of A and mass of B. And of course, you will have to convert that into weight because that's a force, right? Okay, so how do we start? The first step in this is always to draw the free body diagram. Free body diagram of A and B. Okay, so when we want to draw a free body diagram, look, in this case, when the two bodies A and B are placed on an inclined surface, it is always, at least most of the time, convenient to consider x-axis along this inclined surface, right? So it means in our case we are considering this is going to be our x-axis, this is y-axis, right? So if you resolve the forces along x and y, that will be convenient, right? So no dimensions are given. It means all that you have to do is equate sigma fx and sigma fy with 0 and find the unknown quantity, right? So this is all we are going to do. This is a problem where the body is still stationary. The body is not stationary but about to move. Fine. Okay, so consider the body A. Now in case of body A, there is going to be weight, and that weight will be acting perpendicular to the horizontal surface, right? So this is going to be, let's say, this is going to be weight of this, that means it is 9.8 into 9 into 9.8. 9 into 9.8 Newton. So this is weight which is acting downwards. Similarly, you can think about it. This body is about to move in downward direction. That means the frictional force acting on this is going to be in opposite direction. So we are considering the effect of the contact point on A, right? So A is about to slide down. That means the friction offered by the surface will be against that motion. So this is going to be in this direction, and this is the frictional force, and which will be equal to 0.25 into the normal reaction, which we have not shown. Let's say it is RA. Normal reaction is RA, and the normal reaction we can show it like this, right? Perpendicular to this. So this is RA. This is RA. Fine. Fine. Now anything else? Yes, there are two more forces. One is the force P, and this body is moving down. So this rope will be pulling the body in opposite direction, correct? Because action and reaction. So you are going to consider the effect of rope on the body. So you will have a force of tension, let's say it is T. So you have forces T and P along the plane, right? RA perpendicular to this plane, and weight of body A perpendicular to the horizontal plane. So this is the free body diagram of body A. Fine. Now let's move to body B. Again, you will have a normal reaction, RB, normal to this plane. Fine. Then you will have a weight of this. Now this is going to be, 0.25 RA. This weight acting downward, this will be WB. That's equal to B. That's going to be 4 into 9.8 Newton. 4 into 9.8 Newton. Fine. Then we have, what about the frictional force? Now in this case, this body, when it starts moving downwards, this body will be pulled upwards. Fine, because this is a pulley. And when this is being pulled upward, the frictional force will be opposite to it. So the frictional force in this case is going to be, this is the frictional force, right? And I'll write friction as this is equal to 0.25 into RB. 0.25 into RB, right? Fine. And what about here again? This body is being pulled by this rope, right? So this being pulled by this rope, in free body diagram, we always consider the effect of the rope on the body. So there is going to be tension T. Throughout this, the tension in the string will remain same. So T is here, acting downward, right? So these are the free body diagrams. Once we have free body diagrams, all that you have to do is resolve the forces horizontal, not horizontal in this case, along this surface, and resolve them perpendicular to this surface, right? For example, now remember, we have two planes, one is horizontal, another is inclined to it, making an angle 30 degrees, right? So it means the normals to these two planes will also make the same angle with each other. The normal to this plane is RA and RB. The normal to the horizontal plane is weight WA and WB, right? So the normal and the weight among themselves, they will make 30 degrees angle. So this angle is 30. This is also 30, right? I hope you agree. These two angles are 30 and 30. So it's now all that you have to do is, you write down the equation sigma fx. Let's consider body A, and we write down the equation. Consider body A. Sigma fx, we are going to equate it to 0, and this is sigma fx is equal to, let's look at this. Fx in the sense x is in along the inclined surface. Now P is acting towards left, so I'll consider this with minus sign, okay? Or we will find out P because it's acting downwards or leftwards, so we can find out minus, consider that minus P. Then consider T. T is positive, right? Tension. So this is T as tension. Fine. Then we have this weight. When you resolve it, it will be towards left, and it's going to be WA into sine 30, because the angle here is 30, right? So you will have sine 30, WA sine 30, and it will be acting towards left. So WA sine 30, it's acting towards left. There is a force, frictional force, 0.25 RA upward, that means along the surface towards right, so it's going to be plus 0.25 RA, right? This is equal to 0. This is equal to 0. Similarly, we find for the same body sigma Fy, right? Sigma Fy. Now see what is, so in sigma Fy, you will have y in the sense perpendicular to this plane, okay? So you have this weight WA, and it will be resolved along vertical line, right? So this is going to be W cos 30, right? W cos 30, and downward, right? So it's going to be minus WA cos 30, right? And upward force, the only upward force is RA. It's going to be plus RA. This will be equal to 0. This will be equal to 0, right? There is no other force. So these are the two forces. Now, similar equations can be written for body B, right? So you write equations for two equations for body B, and if you can solve these equations, you will get the answer. And the answers are, you can find out first, you will find out T T, so I'm writing the answers here, right? So first step you will get value of T, and this value of T is 28.66, and P is 3.146. P is equal to 3.146. Now see here, actually when you write down this, we have this equation along x-axis, right? So I have considered, so it's leftwards, so I have taken minus P, I put minus P here. But then you can have it as only P and find out the value of P. It doesn't matter, right? You will get the value in terms of, so you don't, like we put X, similarly you can have only P without giving it sign, and you will get the sign, so you will find out the value of P, and you will get the value of P as 3.146, obviously towards left, that means with negative sign, right? That will be your answer. Thank you.